Hello viewers, welcome back to video tutorial on AgentGrid. In this video, we'll be discussing a very important component of our open cyberspace. It is nothing but memory grid. So memory grid provides an comprehensive storage service and also a agentic memory capabilities spanning low-level high-throughput infrastructure storage to a high-level cognitive memory systems. So to know more about MemoryGrid, I request you to go and check our GitHub. So this is our GitHub, Open Cyberspace MemoryGrid.id, where you can check our documentations and also the source code of the implementation. So basically, MemoryGrid provides you a comprehensive storage service and also a different agentic memory capability that we will discuss in some time. So how to access this MemoryGrid? MemoryGrid can be accessed via two ways. One is direct infra level access, and one other is a higher level abstraction. That is, we call it as an agentic memory, where we have 5 to 6 different ways of access. So before going to the second part, first we'll start with the memory grid access at a infra level. So in the infra level access, we have two things. One is context KV memory and via a FrameDB memory. So what is context KV memory? It's a scoped active Scratchpad for a backed by a Redis. So anytime agent wants to store something actively, so it can use this particular context KV memory. And also it is backed by Redis, so it is definitely an in memory. So scoped, again, you will have create a kind of a keys, complex keys, like it is related to agent and a session things. So each entry can be stored as a key value pair of arbitrary JSON serialized. So this is very important. JSON serialization happens here. Uh, JSON serialized dictionaries. It provides a fast and low latency reads and writes for a ephemeral in-flight agent state during the session without requiring an vector embedding pipeline. So this is very fast because it's in Redis, and OAuth on access can happen to the keys that you construct. I'll explain when I'm going through the example. So whenever you want an active Scratchpad, so this is the one that you can use. So let me just show an example for it. So if you go to our memory grid examples, I have a memory grid folder in our code. So this you can get it from our open cyberspace Cosmos AI agent grid service, memory grid. So if you go here in the examples folder, so let me just open this context kv, and also let me just open this dv config. So this is the file where you can directly contact your Redis backend, and you can do a set operation and get operation. So is a simple key value. Context memory is a simple key value store scoped to an agent and session ID. So for set operation, you need to pass agent ID, session ID, key, and a data that you want, JSON serialized data. So then for a get operation, you need to provide agent ID, session ID, and key. So in the backend, what happens is this: it will construct this kind of a key, and it will dump this particular data in it. So in this code, you will see you'll be importing a few things here: Redis client and context KV memory. So the Redis client will create a Redis client object, and we'll pass this object to the context KV memory. So I'm load this piece of code is for loading the env file, so that I'll get some certain things that is needed in the from the env. So right now I'm accessing OpenAI API key here, and right now it's not required though, maybe. So yeah, it's not required. So basically I'm reading the configurations for this Redis. What are the Redis URL? What is the your DB credentials? So that I'll read it from this particular make config. So that file is the function. That function is present here, make config, where it will return on memory config, and it has several DB configurations where these data are read from the env files. For that only we are reading that env. So all those this memory configures all the Postgres, Arango DB, VV8, all these things are available right now. I did only the Redis config. Other things I'll explain later. So I'll be using basically the Redis config, and I create a Redis client, and I'll pass that Redis client to context KV memory class. So now I have a context memory, so which can talk to the Redis backend. So I have, for time being, I have created an agent ID, session ID hard coded, and I can do a set operation. Set operation, I'll send the agent ID, session ID, and a key that I want, and a JSON object, a JSON serializable object. And also again, one more key, I'm creating task state, and also I'm creating one more key known as scratch. So I'm just dump some data or JSON serializable data, and also you can do a kv.get. You have to pass these three things where you can get the user prefs content. And also you can get, like, yeah, this is a kv get. You can ask by giving different keys, you can get the content of those the content of those keys. And also you can always update, so you can just update some value, and you can always set it. So since this keys already exists, you just overwrite the content with the latest content that you have shared. And yeah, this is just to get the updated content. And you have a delete operation as well, so you can do kv delete to delete the content that you have stored. And you have to close the redis close as soon as you are coming out of this particular piece of code, so that the any active connections are there, it will get closed, the terminated. So if you run it, so this is the output of Python example context kv. So you are basically using redis. You have just set some content, and I'm just getting user prefs. This is what we have set. User task, this is what we have set. And now I'm doing an update where I'm increasing the current step, and once after updating, I'm just reading it back. So this is the updated value. If you are accessing a non-existent key, it will return none, and it is just printing a deleted case. So it is very straightforward. Instead of using the redis, you are using this particular library provisions, so that all the backend things is easily handled by these three endpoints. So one thing is, to deploy this, you have to go to our docs. So you just go to docs in the deployment section. So this docs is from the MemoryGrid docs, and you have to go to deployment section. So you will see deployment of other things, but for this guy alone, you have to just scroll down. Yeah, so here is one. So you need to you just have to go to gates folder available, and in that redis.yaml is present, and that file you can see how we are deploying it, how our Kubernetes deployment file is. You need to create the redis secret as well. And so the redis secret, you have to set your password. Right now we would have set some dummy password. You need to set your password and then run the file. So by doing that Kubernetes deployment, so you will get an redis the pod got deployed. So now here you have access to the assumption is you have access to the Kubernetes system, the cluster, and you are inside the cluster, and you are deploying this one piece of redis. So this instance, you can use it anytime for your in the agent. Anytime you want to store anything, so you can use this particular redis where you had access to the your file deploying. You have access to the cluster. So now imagine you don't have access to the cluster, but you want to create a Redis instances, or not just Redis, or maybe a storage. So in such cases, we have a different ways to access. So that is nothing but via FrameDB. So FrameDB wraps so many things. I'll explain again. So this was the Redis directly over phone access. You can without any other services, you are directly talking to the Redis service. So we have a FrameDB memory via FrameDB memory. This is one other internal package, internal tool that is part of a memory grid. Memory grid consists of so many things, but this is also one part of the memory grid. So this, what is FrameDB? It is basically the persistent and shared memory subsystem, which is a part of a AGI ecosystem. It gives AI agents and AGI agent societies, not just one agent. Agent societies, several agents are part of it. A distributed, a multi-modal memory grid. So distributed, as you can understand, it can stay in any of the node of the cluster or any cluster. A multi-modal, you can store arbitrary objects like documents, video, sensor data, model snapshots, AI inputs, outputs, anything, any binary data, all those things you can store it. That's why the multimodal memory grid that can store, route, and retrieve arbitrary objects. You can store it, you can route it, you can take a backup of it, you can retrieve it. So all those things can be done via single unified API, where you can store in memory, you can store persistent, and you can do a streaming as well with via unified API. In memory, we'll use Redis backend, where you can use queues or caching, just like how we used caching here. You can do the same thing. And also In the persistent, we use a TIDB. TIDB is a distributed SQL kind of a DB, which can be elastic, horizontally scalable, means without bringing the system down, you can always increase the capacity of the system. And also it is an ACID, transactional consistency, where it makes sure that any given point of time, the transactions that you have done is always safe and reliable, so that even during the crash of the pod or crash of the system, the last state is always a safe one. So that's why we have used a TIDB here. And also you have an optional S3 backup as well, is as a part of a unified API. And also you have a streaming capability. Again, we use a Redis streams, Redis here as a backend to do the streaming operations through a single unified API. So all this is provisioned under a FrameDB memory, where you have in-memory, persistent, and streaming capabilities, and also a multi-modal facility. So this is, and also a distributor. So these are the things that you will observe in the FrameDB. So our FrameDB, the docs, you can check it here. And also MemoryGrid, higher level abstraction, we'll deal in the second part of the video. So first we'll go and check the FrameDB memory. So this is the README file, documentation for MemoryGrid. So it's a Kubernetes native multimodal multi-cluster memory grid for AI agents and agent societies. Say you have several clusters created within your agentic platform. So you have several clusters or across the regions, anything. So in the every cluster you might have multiple nodes or VMs. So even in such cases, you can use our this FrameDB, so that you can create your memory systems needed in any of the cluster. So this is for AI agents and agent societies, multimodal, multi-cluster memory grid. So let us go to the introduction page. So we have several MD files, introduction, architecture, installations. Let me go to the introduction. So memory grid, as I mentioned, is already in our this particular MD file. So I'll not go again there. So concretely, the repository implements FrameDB. So FrameDB, the storage and retrieval engine behind the memory grid, as a set of small Kubernetes native microservices. So you have certain microservices in this FrameDB. You have a client and a client SDKs that the agents can use for read and write operations. So you have microservices and set of client SDKs. So let us see what they are. So why FrameDB? So let's say you have different kind of a memories, right? So long-term working memory, communication, or a sensor data. So if it is a working memory, you require a fast and short lived. So we have a Redis for that. And if it's a long-term, we have an you require a durable and queryable. So durable is, again, it has to be transact properly without being in the intermediate state. So queryable, you require a proper querying also, right? So for that we use a TIDB. And communication or sensor, you require a producer consumer as a stream, right? So in such cases we use again here Redis. So all this memory, when you require this capabilities, so we have to go with the FrameDB, which is the accumulation of all this. So FrameDB exposes all three as a FrameDB instances. So where be it Redis backed, TIDB backed, or Redis stream backed, we call them as a FrameDB instances that are provisioned on demand. So whenever you need it, you can create it. It's not like you have to create and keep it, and at the start of the project you have to keep it. So you can create it any given point of time. Tracked in central registries. That's very important, addressed by a single logical FrameDB ID. So you use one particular unique identification for it, FrameDB ID. Callers do not need to know where or whether the given instance lives on the local Kubernetes cluster or a remote one. So that's why the multi-cluster is, so whether you have it the FrameDB instance is in this cluster, that cluster doesn't matter. So you just have to use the FrameDB ID. So it will take care of writing it, reading it for you. So that's where the FrameDB is. So what are its capabilities? Unified read-write APIs. As I mentioned, you can write it into Redis, in memory and streaming, and even in the TIDB persistent backends. Object abstraction with type. So you just have to mention type. If it is, you want to store it in Redis in memory, you have to use in memory. If you want to use the TIDB, then you have to mention storage. And if you want to do a streaming operation, then you have to use the stream. Just by mentioning this type, so you are changing the complete backend here. So multi-cluster routing, as I mentioned, so we have something known as routing services and global config services. These are the two services that, like we have told it, we have several microservices. So these are the two important services. So objects can live in any cluster. The routing service and global config service resolves where the given frame ID is or object actually lives. So multi-cluster routing, custom serialization, you can right now for Python writing you will be using pickle, or if you want any other serialization you can use that as well. uh, then backups and restores, so you can configure if backup is required or what key you want to backup, so all those things is possible. Kubernetes native provisioning, so create a FrameDB instance dynamically, creates a Redis and TIDB deployment service and PVC in a cluster. So you can create n number of Redis instances, you can create n number of TIDBs, you can create n number of Redis instance in a same node, you can create n number of TIDB instance in same node or across the cluster. All those things are possible. And client side caching, so we have two SDKs, like as I told, we have microservices and client SDKs. We have two SDKs, one is FrameDB SDK and one is Object API SDK. So FrameDB SDK is a preferred one, and it includes even the caching of data. Let's say some data you have pushed to the DB and you are retrieving it again in the same code somewhere, so that value will be cached until unless you want it on you want it from the DB. You will get a cached one. You can configure the how much the caching should be, like say in terms of memories, maybe 10 MB, 20 MB. So those things you can configure it. And also we have a caching for connection pool. Let's say you have hundreds of FrameDB instances. FrameDB instance could be Redis. FrameDB doesn't sorry, the TIDB doesn't matter. So if you have hundreds of such FrameDB instances, you have again you have to maintain a connectivity, right? So you don't have to keep connected to all. So we again have a pooling system here, so you can mention how many maximum I can be connected. So those things are also possible in the client side. And also we have in Object API side, we have again two kinds of services. So two ways you can do a writing. So one is rooted gRPC object service. We have one separate service. If you are interested in gRPC access, we have something known as object service. So via that also you can do a type here is like you need to define what the structure of the input and outputs. So typed routing aware writes, so it will take care of routing all those the routing thing it will take care. And also a direct ad hoc writer, where you will not go via the routing rights, you will directly bypass that and you will directly write into the DB. So we have two ways, two client side client the highlight is I'll go and explain again in details. We have two client codes, one is FrameDB SDK and Object API. So um, so yeah, so this is a high level data. So application or agent code you have, and we have FrameDB SDKs, we have FrameDB writer client. So this is basically nothing but that the second agent SDK I was talking about, second FrameDB SDK. And we have a we can do directly gRPC or HTTP calls as well in application code. So instead of you doing and remembering and noting down all the APIs, so we have it wrapped it in FrameDB SDK. So you can use either FrameDB SDK or FrameDB writer client instead of you doing in raw HTTP or gRPC calls. And this the second library, the SDK, is only for a writing purpose. It cannot be used for a reading purpose. That is a limitation currently. So that's why we prefer you to use this FrameDB SDK. So we have FrameDB SDK, FrameDB writer client, and raw HTTP. Those three things are possible via your application code for the FrameDB access. And the service wise, in FrameDB we have global config, routing service, and a object API. So this API is a gRPC exposed. So you would be like this FrameDB writer client, in between inside it will use this particular APIs exposed via object API. You can do a set object, get object, and talks to Redis, TIDB. I mean either this these two these are RPCs. So RPC is nothing but the function call. So we'll be using these two function calls, or you can directly talk to Redis DB TIDB directly, so without going via the gRPC, but via this service only. So that is also possible in this particular client. So what is global config? since you have, as we told, like multi-cluster is possible, right? So to know, first of all, you have to you cannot talk to individual clusters. Instead of that, you require one service which can talk to those clusters. So this is what the global config service is. So it is an instance, it has a registry of the instances, meaning whenever you create one FrameDB instance, it will be first noted down in this registry, uh, like which node, what cluster it is, and what is the name of this instance. All those details will be pro, put in this registry, and also it will help us in a cluster resolution. So next time, anytime you create a FrameView instance, you say which cluster and all, and whenever you are going to dump the data, right? So this again, it'll help in basically multi-cluster access. So while dumping the data, it will come to the routing service. So right now you are going to dump the data into the DB, or you are going to access the data. So then comes the routing service, which will take care of helping you in getting the details that you want from the DB, or dump the DB data to DB. So it notes down, again, it has a registry. What it notes down is uh, what object, it just stores the metadata. It will not store the data itself, it just stores the metadata. Here you are trying to dump this particular key in this particular FrameDB, and this is the details of that. It is just the metadata, it keeps the metadata of it. Every data you dump, it will have the metadata here, but actual data resides in the TIDB and FrameDB. So basically we'll be using all these services while dumping and acquiring the data from the DB. We'll be using these services. So the global config, as I told, it is one single individual service that is available across all the clusters you have. Right now, this will be exposed to the user via node port. This will be exposed to the user via node port, and this service is also exposed via node port. But per cluster, let's say you have one cluster with 5 nodes, one cluster with 7 nodes, one cluster in some other region. So every cluster should have one service that is known as a config service. Here it's a global config service, and one other is a config service. This is the per cluster. So basically global cluster will talk to the config cluster of that cluster, config service of that cluster, and it will take care of doing things that you wanted to do. Meaning you want to start an FrameDB instance in this particular cluster, one of the cluster. So you just talk to global config. Global config inherently will talk to the config cluster, config service. It will take care of, because anything you want to do in this particular cluster, it has to come to this config service. So this has a Kubernetes config with it. Like since you want to create a pod or deploy a pod, right? So the config is provided to this service. So this config service has the Kubernetes configurations, and it will take care of creating the deployments, Redis deployments or a TIDB deployment. So config service is per cluster. Global config is a for all the cluster, only one service exists. Similarly, routing service is also one service, and also object API is also one service. So this is the overall high level architecture of the FrameDB. So so let's go in detail about the architecture. So basically it contains four Python microservices. The If you go to the source code of this memory grid, right, you will see four microservices. Let me just go to yeah, if you go to services, you will see a config service, global config service, object API service, and routing service. So ignore this source DB and decode services. Right now I'm not going to explain those, so you can ignore this. But this config service is what per cluster. Global config is entire all the clusters. Object API and routing services are, as I mentioned, it's for gRPC and routing services. So you will get access to this object API service, public access, your routing service, public access, global config, public access, because they are exposed via node port. So we have four microservices and two client SDKs that I have already told. We have two clients. One is a FrameDB SDK, and we have one writer client or object API client. So and also a Kubernetes installer. So yeah, we have a Kubernetes installers as well, because we need to deploy all these services, right? So all the 4 services we need to deploy. So for that we have a Kubernetes installer as well. So this page documents every services, its internal modules, and what each function does, followed by how the pieces fit together. So we just get into it. So service overview. So we have a, as I mentioned, config, which is running in 5000 port internal port. It's a Flask app. It also has a MongoDB. It uses a MongoDB because it's a registry, right? At the end, it has to have a registry. So for all the registry, we use a MongoDB here, and all the DB name will be FrameDB, and individual different collections will be there. So config service uses on MongoDB. It has a FrameDB named DB, and it might have a different collection. So so what this service do, this config service will do, it is basically does provisions the Redis and TIDB deployments inside the local cluster, and also records them. So basically, whenever you want to create these deployments, this service is responsible for doing that, and also it maintains the record of that. So global config service, it's also again running in 500 internal port and a Flask app. It also has a MongoDB. This is responsible for multi-cluster instance registry, and also it proxies create and delete calls to the right clusters config service, and also bootstraps the config service itself. Meaning, to set up this config service, you use this global config service. Once this global config service is there, anytime you want to create or delete anything you want to do, you will be using this global config service. So routing service, as I mentioned, it also has a FrameDB, because it also has to maintain a registry where individual keys are. It also has to maintain a registry. So it tracks where the object and string lives. It just has the metadata details, not the content itself. Which FrameDB, which copies, all those details it maintains. And we have Object API, gRPC exposed service. So it talks to Redis TIDB directly, and the actual data path. So we have two RPCs, set object and get objects. So that you will be using to set and get the objects from. And all the 4 services share same MongoDB instances. Database name is FrameDB, but uses a different collection. So they can be deployed as an independent Flask gRPC processes. So let's see the config service. So it's a per cluster. FrameDB is basically an FrameDB provisioner, we can call it as, because it is responsible for creating the FrameDB instances. So in the cluster, so it is a FrameDB provisioner. So this is the the config. I have shown all the folders. So config, all those folders I have already shown. So this service runs once per Kubernetes cluster, and it is only the service that talks directly to the Kubernetes API within the cluster to create and destroy the Redis and TIDB workloads. So I'll not go in detail and explain this file. So this file explanation is required for those who want to be co-develop along with us. So it's for them. So but for a end user, this is not the content. These contents are not required. But on a high level, so how to create in-memory instance registry, how to create a persistence instance registry. It is about only the creations. So how to use that, we have the separate functions here, like insert, update, delete, query, get by id. So how to do it for in memory instances, these functions will take care. So if you have a for persistent memory, how to do the dumping and all, right? So you have a details present in db persistent.py. So the core kh.py is for a Kubernetes provisioning, meaning whenever you try to create one FrameDB client, so FrameDB instance, so this config service, it will use this kh.py to provision. So to deploy those services of whether it is a TIDB or Redis instances, this Python file will be used. So and also you have a, whenever it creates a Redis instance, it creates a Redis exporter as well. And also it can take certain the parameters. If you want to set some parameters to Redis, it can expect the parameters from the user as well. Whereas for persistent DB, it uses this particular ping cap TIDB, and also it creates an PVC, persistent volume claim, at this particular path of that node, and also a node port is also exposed. So this is for persistent DB. So this is the orchestration layer. So basically, whenever you call API, it is a single API, and in that single API, it will take care of routing, whether it's in persistent or direct in memory. So that orchestration, this Python, this file will take care of. So APIs, these are the APIs exposed via that class cap. So this you can see the what all APIs are present in it. So and then global config. So yeah, you need to pass an environment variable Mongo URL. So it is a connection string. So and also you need to pass the cluster public URL. So whenever we create a cluster, it has something known as public URL. That also we need to give as an input env variable for this particular service. So we have a global config, which is a second service, a multi-cluster registry, and a cluster bootstrapper. So cluster bootstrapper is nothing but this service only creates the config service that we have discussed in earlier in the previous this was the service. So global config, when config only knows about its own cluster, global config knows cluster aware front doors. So it knows about all the cluster. It is a service client normally talk to. So it's a service client, right? So we only talk to this particular service. So it forwards provisioning request to the right clusters config. So even if you have multi clusters, it knows it knows what all cluster configs are there, and it will talk to them and keeps the registry that also stores the cluster ID. So instance from any cluster can be located here. So it is similar, like whatever the config stores, same thing it also stores, but again it will keep one extra key known as cluster ID. So core DB, so this is similar to what you saw in earlier, but along with that it gives one extra field known as cluster ID. So whatever the details this DB stores, it has one extra field like public URL, local URL, status, to date, node ID, port ID, metadata, right? Along with that, it has one more extra ID known as cluster ID. So core db.py, then yeah, cluster db.py is a cluster resolution. So how to resolve the cluster, what cluster it is. So for all those details, this file will be used. So let's say you in your experiment you don't have a multiple cluster, you have only one cluster, right? So in such cases you need to set this up true. So it means there is no multi-cluster, only one single cluster is there. And also you need to provide the FrameDB config URL, nothing but the single clusters. This clusters, the config service will be running, right? That URL you need to provide, so that it will not go and check what all clusters are there. So it is directly one cluster, so you need to provide that. So and yeah, so that's it. So for one cluster you need to set this, and you need to give the config URL of it, so the config services URL of it. Then proxy in memory, so proxy persistent, so it is a proxy services. Basically create a proxy, create instance, delete instance, set redis config. So those are simply a proxy. It will just pass on this to the config service, so that's why we have called it as proxies. So then orchestration layer, so this is the main entry point. So the global DB, FrameDB, node ID, all those informations we gave it here, but it will resolve whether it has to go to in memory or persistent. It will take care of orchestrating that. And local config bootstrapping, so whenever you want to create a service, right? So config service in one particular cluster, this is the file that will be used. So next is a API. So what all APIs are exposed from this particular Docker service. So I mean this service. So you can check the APIs here. And next is the third service is the routing service. This is basically object and stream metadata catalog. It will not store the data, the exact data that you have dumped. It will just store the metadata only. So this service answers the question which FrameDB instance hold object X. So basically a simple key it will hold, and it does not store the object byte itself, only metadata about where they live. So you have FrameDB ID, FrameDB type, object IDs. Um, this is basically the object ID is always a basically a Mongo ID. So whenever you dump something into the actual TIDB or a FrameDB, so a registration will needs to be created in MongoDB, and that ID is nothing but the object ID here. And this is FrameDB ID. So basically, which FrameDB it is, you might have several FrameDBs in same node, several FrameDBs across the cluster. So the FrameDB ID will be keeping it as a metadata. And also copies. Let's say same data is copied in multiple FrameDB instances. So that data also will be present in this copies. And also the FrameDB data type, and also the size, and also any other metadata you want to give. So you can give it when you are dumping the content to the FrameDB instance. So stream object, it will meant it remembers the it down no puts the data like queue name, FrameDB ID, metadata. So these three things it will put for the stream object. So db.py, it is mainly about add a copy, remove a copy exist. So this function, this py file will doing helps in doing all this: insert, update, delete, query, get by id. So if you are doing this kind of operations, right, so this uh, py file will be used. So add a copy, let's say you have dumped one data into one PriviDB instance and you want to duplicate it in one other instance as well. So then you will do an add a copy, or a remove a copy, or copy exists or not. So this kind of functions are present in that. And also you can check other APIs. So since it's a routing service, it will not dump the data. Like when you do a add a copy, right, it will not dump the data to a new DB. It will simply adds a reference, like it will update this copies only. It will not copy the content and put it into a FrameDB. For that we have a separate service, separate functions. So this is, since it is a routing service, it will just about the metadata. So for metadata copying and all, we have this. So next is a object API service. So gRPC data path gateway. So those who are interested in gRPC ways of access, so we can use this particular object API service. So this is the only service that reads, writes object bytes, and it exposes a small gRPC object service defined in, this is the file where this service are defined with the two RPCs. Basically they are set object and get object. RPC is remote functions. So internally resolves where to read, write via global config and routing services. So this service also uses the global config and routing services, and internally it uses that, but you will not be able to see that. The system will take care of. So this is a proto configuration. So you have set object, get object, RPCs. So it has some request and response class. So that is explained here, what all the content and what is this object class. So those are available here. So again, it has some functions here: Redis interfaces, TIDB interfaces, cluster client, object routing client. So I'll not go in detail about those. So we'll see a example, then it might be little clear for you. So grpc server.py. So yeah, so next, these are 4 services that we have. So one is a grpc service for you to do that grpc connection and dump the data, or else you have a global config routing service, and you have a config service. So in since 4 services are done, so let me go to the client side SDK. So we have FrameDB SDK, and we have one other SDK that I'll come back. So for FrameDB SDK, it's in high level, and this is the recommended. So I prefer user to use this particular SDK. So we will discuss again in detail about this SDK. So you have cache.py, basically about the caching, where you can mention the how many recently accessed data, how many bytes you want to keep it in your cache. So that can be this the uh, Python file for it. And connection cache, it's about how many DB connections I need to keep. So if you mention 100, so it can keep totally 100 connections active. So if 100, if you are adding one more new connection, the last one, the least use will be going away. So basically we'll maintain a key value pair for this connections. Recent connections will be stored here. So FrameDB ID, interface memory.py, interface storage.py, memory is for in-memory, storage.py is for storage, which is TIDB. So you have two interfaces here. Again, this is the implementation detail. So what all APIs are present in it. So you have a bulk read case. You have we will again, yeah, what all APIs are present. So you have several APIs that I'll explain here, but again, this is the file where all those APIs are. So read, write, backup functions, mirroring, everything is present here. So directly this will directly talk to the Redis and TIDB instead of going through the gRPC service. Here it will not go to gRPC routes. It will directly talk to the TIDBs or Redis DBs. So the with the help of this service, so you will create, you basically, the object API is one centralized service where gRPC can be monitored. So how many calls are happening. So if in case you require that kind of a ways, you can use this object API. If not, you can use the FrameDB SDK, which will directly talk to the these DBs. So what all APIs are exposed? Set Pythonic object, get Pythonic object. So if you are interested in let's say Python content, the by default it is applicable. If you want a custom serializable, let's say you have some class, let's say datetime object, you want to serialize it. So then you need to use this get Pythonic object and set Pythonic object APIs. If you want to store any raw objects, so then you have to use the set object and get object, any binary data or anything you want to set, right? So you can use the set object, get object. So any Pythonic class objects constructs, you can use the set Pythonic object, get Pythonic object. So create a backup, create a bulk backup, so copies an object or list of objects from one FrameDB ID to another. So backup copies one ID to another, and backup to object storage, restore from backup. So if you have S3 kind of object storage, you can back it up to the S3 buckets as well. Or if it is not, if it is custom, let's say instead of AWS S3 you have some other Google or anything, then you use a object storage backend custom subclasses, and you have to implement certain functions that will also possible. So listen for stream data, pull all stream data. So this is basically a stream listening. So you want to get the stream data, or you want to pull all the data available in the stream, then you need to use these APIs are also available here. So listen for stream data is a brpop, and drain all is a rpop. So B here stands for blocked. Since we are using a Redis backend, so this is the command that it uses internally. So write pop, so blocked write pop, until unless something is present, it will not exit out of that. So it will hold until unless something is there in the queue. So rpop, it is not a blocking one, it will simply pull all things available in that queue. So that's where the pull all stream data will be used. So bulk read, bulk fetch from the persistent DB. So it is for a bulk read from the TIDB instance. So it will basically do select star kind of a operation from the TIDB. So we have a global cache, connection cache, things like that inside this, implemented in this particular SDK. So we have second SDK, FrameDB writer client. So as name suggests, it's only writer, it cannot do a read operation. So it's a low level ad hoc client, useful when you want to write data without pulling in full caching SDK. Since here you, as you have seen, it has caching and all, right? So if you don't require, you want a lightweight SDK, then this is the one, but it can be used only for a writing operation. So we don't prefer this to be used. So we cannot read, we have not added the reading interfaces. So let's not use this. And when you specifically want to go through a RPC object service, right? So then this is the library that you need to use. So you cannot use a Python SDK. So if you want gRPC writing, so you need to go with this. So I'll not again explain in detail about this details. So let us yeah, so in this library also we have one direct way of access. So we have added FrameDB writer and objects API. So this object API is for a gRPC, whereas we had on FrameDB writer also, where it directly talks to Redis DB and TIDB by passing the this objects API entirely using only public URLs resolved from the global config. So since every cluster, FrameDB cluster that you create will have a public IP and local IP. The local IP is for accessing within the cluster, and public IP is anywhere. So any cluster can access. Let's say cluster 1 accessing one FrameDB instance of a cluster 2. So in such cases, you have to use the public IP. So here, this FrameDB writer method, you can use it directly to access the Redis DB and TIDB, but by using the public URL of it. So that's one other piece of one other version of the library. Instead of object API, you have a FrameDB writer API as well. What happens when you write data to an in-memory object via our SDK? So basically, you will be using this kind of a function, set object, or get object, or set Pythonic object, or get Pythonic object. You will be basically calling this kind of functions where you provide your details like FrameDB key, data, all those things you will provide, and also you will provide an option of type, whether it is an in-memory or a storage or a streaming. So when you provide this, what happens is get instance by ID. Since you have mentioned this is the FrameDB ID I want to write. So first of all, it will check whether that FrameDB ID exists. So basically this function will be called, and internally it will be doing a curl operation to the global config, and global config This is the endpoint it will be using, whether it exists or not. Since it exists, you will get a return of data. So you will get a public URL, a local URL, and a cluster ID, all those details, whatever during the creation time you would have given all these details. So public URL and all local URL, the Kubernetes will try, I mean, the service will, whenever the global config service creates it, it will try to dump those details. So that details will be fetched and returned. So from that, it uses a local URL. So it sees whether, and also you have to provide a cluster ID as a env to the client code wherever this client code is running. So when it receives that, it checks whether it is a local, whether it is a cluster ID that it has received. Cluster ID, which is here, is same as what is there in the env. If it is so, then it prefers the local URL, because client code is also in local cluster, and also the DB is also in the local same cluster. So it uses a local URL, or else it uses a public URL. So here we have a Redis interface, and we'll pass that URL, and we do an set operation, key and data, right? So it divides into Redis. So this basically dumps the data into the DB, Redis DB or TIDB. But that's not over. So you are having a cache, right? So it will update that details to cache as well. Global cache dot add, this is the key, this is the data, this is the metadata. It's a local LFU cache, client side only, not the server side. Is a local client side, so it is available only within this particular library. So then once cache is updated, again you have something known as object counting client, routing client. Basically it talks to the routing service. So it dumps this metadata. So whatever the metadata is there, right, for this particular key, related to what key, which frame DB. So the metadata structure we have seen in the top. So basically it updates that. So what it uses from routing services, it uses frames, frame DB objects. So this is the endpoint it uses, and it dumps the data so that it will be available in the routing service. So whenever someone queries it, so it can use this details from the routing service. So this is what series of things that happens when you do an set operation. Similarly, when you do a get operation, so any process pointed at same global config routing service URLs will check the local cache first. So basically, it's just, if it is a key is same, it checks the local cache, and it if it is available in the local cache, it gives that. If it is not available, it's a miss. Then it queries the routing service, resolve the instance via global config, meaning it will talk to the routing service. It will try to get whether this key exists in the routing service. Since the key exists, or if it is not doesn't exist, it says no. But if it exists, then you will get the details like which is the cluster ID, what is the cluster ID, what is the URL, all those details. I mean, what the metadata which is stored in the routing service, it will get it. From that, it will try to talk to global config, and it will ask about its public IP and local URL. And once it gets the public IP or local URL, it try to connect to the Redis DB or TIDB, and it reads the data and gives it back. And also it updates the populate its own cache, because there was a miss, so it updates the cache. So this is what happens when get object. Basically all the APIs that was there as an I'll show you again all the API. So those APIs will be used internally by this particular client core. So let us see what all services. So we have a config service, we have a FrameDB config, we have a routing service, and object API. So this FrameDB config is nothing but our global config. This config service is nothing but a config service that we are talking about. So here you can see only three services as a node port. So global config, routing service, and object API, only three has the node port. 30610, 30611, and 30612. So that only these services can be accessed publicly. These services publicly access is not possible because they don't have a node port access. So if you want to do access anything, you want to go into the cluster and you have to access them. So and also, or any instances of FrameDB you created, let's say be it in memory or the FrameDB or FrameDB storage. FrameDB namespace is for Redis and in-memory instances. Redis in-memory or queue streams instances. FrameDB storage is nothing but a namespace for TIDB instances. So this FrameDB instances, the port range from 30,700 to 30,900, whereas for this 30,900 to 30,999. So let me just show you our namespaces. When I do in my cluster, when I do get namespaces, you will be seeing FrameDB, FrameDB services, and FrameDB storage. FrameDB is for in-memory Redis, and FrameDB storage is for a TIDB. And this FrameDB services is for the service where we have 4 services, right? It is that namespace. So let me go inside the kubectl get pods -n FrameDB. There are 3 already FrameDB instances are running, 1, 2, 3, and in the FrameDB storage, there is already one instance which is running SQL 003. So if you check our FrameDB services, you will see 4 services: config service, FrameDB config, which is a global config service, object API, and routing services. So these 3 services are accessible via uh, public via node port, and this is the internal service. So right now, this service will be only one service, this also will be one service, this also will be one service, but this service varies from cluster to cluster. So since I have only one cluster here, I have this config service here, but if you are going to check in one cluster where these services are not there, you will see only the config service. Let's say cluster 2, there only config service you will see in this particular namespace. You will not see this because these 3 services are one for all the clusters. So this is the architectural layout of full of our repo. The whole architecture I have explained here. So let us see the FrameDB instance. How to create a FrameDB instance. So creating and removing a FrameDB instances. FrameDB instance is a single independently addressable storage backend, one Redis deployment or a one TIDB, anyone, like it could be a Redis deployment or a TIDB deployment, addressable storage backend, independently addressable, identified by a FrameDB ID. You choose whatever the name you want to use, you can give, but any given point of time, only one unique ID can stay in the FrameDB registry. So objects and streams are always written into specific instances. So we have in-memory and persistent, as we already told, and the in-memory instances can be accessed via /framed/instances. This is for a local access, like if you are doing something in your cluster, you will do access like this. But if you are accessing via global config, you will access via this way. So this is via config service access, this is via global config access. So global /framedb/instance, and you would use in memory or stream for the in memory thing. Whereas for frame TIDB, same thing. For local access in the within the config service, you will use FrameDB persistence instance. Whereas if you are using something outside, then you will use a global FrameDB persistent instance. So you normally talk to the global config service, not the config directly. This is very important. You will not be able to talk to this service because that is a multi-cluster aware entry point, and one on the client SDK expects, and config is an internal service that global config calls on your behalf. So now 3060 is a global config. I have already told. 3061 is for a the routing service, and 30612 is for a open the gRPC service. So to create an in-memory Redis instance, so you will use that global config URL, which is in 30610. You use this API global FrameDB instances, and you will do a post operation. In that post operation, you have a FrameDB ID. You have to give an unique ID. If this ID is already taken, it will say this ID is already exists. So node ID, and you have to give a node name. So let's say in your cluster, you have a cluster ID also. So by default local cluster, because right now in my system I have only one cluster, so that's why whether you provide it or not, by default it's a local cluster only. So in this cluster, let's say you have multiple nodes, so those node names has to be labeled. So let me just show you that. I can show. So as you can see here, there is a node ID label, there is a node ID label. So node 1, node 2 given to these 2 nodes, worker nodes. So you need to have the node ID labeled nodes, and that node ID is what I'm giving here. Any metadata you can give, key value pair, and also since it is an in-memory, it is an in-memory FrameDB instances. So you have to say what all the configurations for the Redis. Since we are using Redis, you have to send some configurations needed. So you can check the Redis documentation for all the configurations. So what happens under the hood? Global config resolves the target cluster's config service. Basically, it knows for this particular cluster ID, where is the cluster service config service. So it will talk to that, and it calls the cluster config service post FrameDB instance. So as you can see, we have used global FrameDB instances, but a global config service will use a FrameDB instances endpoint of the config service, which creates a FrameDB namespace if it doesn't exist. So we have seen that the FrameDB namespace is created, right? So the FrameDB namespace is created. If it is not created, it creates it, picks a free node port from this particular IP because it's for in-memory. This is the range of the in-memory IPs, so ports, and it creates a Redis deployment with a Redis exporter sidecar and also node port service so that it can be accessed publicly as well. So now a global config records the instance including public URL and a local URL, because once the service is running up and running, you will get public URL, local URL, and cluster ID, all those details, its own registry, it will just note down. So you will get response of this kind. So if you want to create a TIDB instance, so you go again global FrameDB persistent instance. This is the change. So from here it was instances, but here you say persistent instances. Then it is about a TIDB creation. So again, same thing you need to provide, except that the storage size you need to say, wow, how many GB of space you want to consume for this particular, so that it provisions the PVC, PV and PVC can be claimed at varlib TIDB. So it happens in one of the node PVC. So this path will be taken by the PVC, and it will create a node port service as well. It creates this particular it uses this particular container image, and also it uses this particular node ports. So it has a local URL, and it just dumps all this data in the global config. So if you want to know the all the the instances, you listing instances, you just have to use this curl command. So all in a memory instances, if you want in memory instances, you have to use global FrameDB instances, and you are talking to the global config only. So you have to use a global instances cluster, and what is the cluster name. So local cluster is the cluster that I want to check. You will get all the FrameDB instances. If you want to check instances that is in one particular node, so what you need to do is clusters, the local cluster name, and node, and what is that node ID you want to check. So if this node has several FrameDB instances, it will just list them all those instances. So free form query, you can do that Mongo kind of a query as well. So you just have to pass the status, the key value pair you want to have to pass, similar to the Mongo document. So here you have to use a query. So here it was a cluster, and after that the cluster name, node name, but here it directly query. So this is for a in memory. So if you want to check something for single instance by ID, right, so you have to say directly demo instance. This will take directly to that particular instance. It will just say whether it is available or not. So a persistent instance have equivalent, this whatever you saw here, you have the same thing, but instead of instances you have to use the persistent instances replacement we need to do for the above URLs. So updating runtime Redis config. So to change the running in memory instance Redis configuration without recreating it, let's say you want to increase the max memory. So you have already created the instance, and you just have to update it so that the Redis can take that effect. So you have to use the global FrameDB set config is the endpoint. So FrameDB set config is the endpoint, and you need to tell what is the FrameDB ID and what is the config you want to update it. So this connects the instances Redis via local URL. So basically it talks to the config service, and it uses its local URL on the cluster that actually hosts it, and issues a config set operation. And this is how we do it in Redis. So you want to do any config set, so you'll use a config space set, and what is the key, what is the value for each entry change live but not persisted. But only the problem is this will not be persisted. This is a live event change. So if Redis post restarts again, it will go back to the what it has started with initially. So it is basically we are not writing it back to the Redis config. We are not writing it back to anywhere, right? So that's why it is not a persistent. So removing instances, you have a global FrameDB instances. Directly you can remove one instance. If you want to remove the persistent, you just have to replace the persistent instance. So this locks the instance up to find its cluster ID. So basically This I'll identify which is a cluster ID, ask the cluster's config service to delete the Kubernetes deployment and services, and for persistent instances, the PVC also will be deleted. Then the removes the record from the global registry. These are the backend that things that happens in the back of this particular API. So removing an instance does not clean up routing services records that point to an object stored in it. So right now these APIs will simply delete the instance. It will not, since you have a routing service which maintains the records of which key, which cluster, which FrameDB, right? So it will not be cleaned. You have just deleted the instance only, FrameDB instance only. Those entries will become a stale and point at now missing instance, because the instance is deleted, but the data which is there in the routing services still pointing to the deleted instance, so it becomes a stale. So if you are decommissioning an instance permanently, also delete or migrate any object or streams registered against it via the, we have a ways of doing a regition or decommissioning or a permanently moving ways we have it. So we'll explore those APIs. So single cluster local mode. So if you are running a multi-cluster setup, use if you're not using a multi-cluster setup, right, that's what I was saying, use this particular variable, use local cluster to true, and FrameDB config to the uh, the local config service, the config service URL, one config service that you have of the cluster. So on global config, this is exactly what the bundled FrameDB config, I mean, if you see this, you will check, you will get those details. In this mode, the cluster ID in your request is still required by the schema, but it is not used to look anything up externally. So though you are running it as a and you are not running a multi-cluster, though you have made it as true and you are given a config services URL, but still you need to pass the cluster ID, because that is a schema checks happens, right? So you have to pass this cluster ID, but it will not be used. So but since you know you have hard coded the config service, it will take that only anytime. So this is for a single cluster setup, single cluster mode. So bootstrapping, so let's say you have onboarded a new cluster and you have to create a config service. So how to create the config service? So if you are onboarding a new cluster into a multi-cluster memory grid deployment, global config can deploy the config service and its own MongoDB as well. So into the cluster for your given Kubernetes config, you need to provide a kube config. So that's what the kube config is, and it is the URL for it. So storage side also you need to save for the MongoDB that it's available here, and you need to check the status of it, whether, and to remove the uh, config service from that cluster, you can use the /remove. So FrameDB config is the endpoint you need to choose from the global config service. So global config service, this deploys into the FrameDB config namespace. It deploys in Mongo 6.0 deployment service, and also it creates a config, and it also creates a 32566 node port. So this is the job of this API, bootstrapping a new cluster config service. So let us go to a client SDK. So client SDK, we have seen there are two SDKs. So first we'll see the FrameDB SDK. So we have other SDK also that we'll check later. So FrameDB SDK is recommended and high-level Python client for FrameDB. Unlike Write SDK, which is the second SDK, it supports both read and write. Whether the second is only for writing, talks to Redis TIDB directly, not through the gRPC service. So it doesn't use the gRPC, directly talks to the Redis clients, and adds two client-side caching layer plus Pythonic object, backup, restore, streaming helper. So all these things are present in this particular SDK, as I explained already. So installation, right now you don't have to install, you just have to, those SDKs are already bit. If you go to MemoryGrid, agentic, the FrameDB SDK is already present, so you can use that SDK directly. Um, so yeah, dependencies are present here, and so how to initiate it? So FrameDB SDK, import FrameDB client. You need to provide a global config URL and also routing service URL. A global config service is running at 610 port 3610, and 3611 is for a routing service that you need to provide. And then you can use a set object and a get object. Set object, you need to pass key, FrameDB ID, binary data, and a type, whether it is an in-memory or a storage or a stream, and a metadata as well. So in the backend, it understands what is this type. Oh, it is if it is an in memory, it uses a set operation because it is just a Redis setting value or some key value set. If it is a stream, right, so then it does an L push. So L push is for a Redis L push, so it does an L push so that the content, when you receive it, the receiver end can get it as a stream of data. So where Redis queues are used. So if it is a storage, it uses the TIDB equivalent of setting the content. So again, you can give a metadata as well. Some metadata you need to provide. So this is for a writing operation. Similarly, you will get a for a get operation, get object. So this is for a set and get object. So you need a cache bytes and a connection cache size also. Like you can pass those how many bytes of data it can hold at max, and also how many connection URL it can hold max. So those also present. So that also you can set it. Defaults to 100 and defaults to 100 MB. So how reads and write happens, that I have already explained previously. Like it will go to local URL, public URL, or a local URL based check it will do, and it updates the cache, and also that I already explained. So storing arbitrary Python object. If you want to store arbitrary Python object, like Python classes object where pickling is required, right? So you will use a get Python object, set Python object kind of a API. So they rebase same. So you pass here you are passing a dictionary here, whereas here you are passing a key value pair. Python set Python object, key, agent state, object, any Python serializable, like pickle serializable class content you also you can give, and FrameDB ID, FrameDB type. This for get Pythonic object. So a result found will be present. If it is there, then it means it's a boolean, it's true, so you will get the content. So pass a custom serializer, deserializer. You can pass custom serializer, deserializer for this particular set by and get, where it should have these two functions, like the class that you have given to it, right? It should have this serialize and deserialize functions if you don't want a pickle. So for cross language interoperability. So if you prefer not pickling, so you want any other, so you should have a class which should have serialize and deserialize functions in it. So this one some sample example: JSON serializer, serialize and serialize. In the serialize, you just return a JSON dump socket with encoded string encoded, and deserialization you will do just a JSON load of it. So if you pass this class, right, serializer equal to JSON serializer object, deserializer equal to JSON serializer object. If you pass this, it will take care of calling these functions whenever it has to do an serialization and deserialization. So backups between FrameDB instances. So this API is like creating a backup. So this is the key that I want to take a backup from. Uh, I don't have to pass the source FrameDB because the routing service will know where it is available, and it will do an backup to the target FrameDB. So target FrameDB instance I need to provide. Then create a bulk backup. You can give multiple keys, so it will do a bulk backup as well. Internally, this is a get object from the source followed by a set object against a target FrameDB. That's it. So nothing extra it does. So gets from the one FrameDB and set does a set operation in the other FrameDB, preserving the key, data, metadata, and type, everything common. So now backs to and from external object storage. So let's say you have an S3. So that S3 you can use backup to a object storage API unit use. What is the key? What is the FrameDB ID? And what is S3 credentials? So this you need to provide. S3 credentials is a dictionary. So again, this is for a storing to S3. So if you want to retrieve from the S3 and put it into some FrameDB, then you will restore from backup. This is the key uh, in the this FrameDB instance, and this is an in-memory type, not a stream type or any other storage type. It's an in-memory type. You need to mention that. And what is the S3 credentials? So uh, this restoration from the S3, this key will be read and restored into this particular FrameDB. So next is for streaming. So streams are Redis list addressed by a FrameDB instances plus a queue name to it, queue name as a key. So if you want to access, you have set object, get object, right? So in the set object, if you do instead of in memory, if you type pass it as a stream, then by default the library understands that it is an stream. So so it will do an L push from there. So you can do a BR pop. So listen for stream data. If you call this API, it is a BR pop. So it will get blocked here until unless someone has put some content into the key that you have given. This is the key, which is nothing but a queue name and a FrameDB instance. So until and as it gets something, it will be blocked here. So once it gets the content, it will go back to the next lines of the code. So if you want to drain everything that is available currently in the queue, so you can use pull all stream data. So here listen for stream data, pull all stream data. It does a BR pop, it does a R pop. It does a R pop one by one completely, and it gives you the all the content. Uh, to produce a stream items, use set object with type equal to stream. Yeah, this is what I was saying. In the set object, you use type equal to stream, and it does an L push. So left side push, right side pop. So it becomes a FIFO, first in, first out. So bulk reads from persistent. So if you want to do a bulk read from the TIDB, you use this API bulk read. What are the keys and what is the FrameDB ID? So it will read at once. Whereas all this bulk reads, right? So pull all stream. So it does one by one. Whereas here, it since it's a SQLite, so select key data from, it can at one go it can pull all the content from the TIDB. So this is because of the way the API the TIDB feature of it. So that's why we are able to get it in one go. So FrameDB method references set object, get object, set Pythonic object, get Pythonic object, create backup, create a bulk backup, backup to a object storage, restore from backup. So all these functions we have express bulk create, pull out stream data. So we have seen this. So just to give an API references, we have seen few APIs. So for config services, you will always use the FrameDB instances. So this direct API, you will not be calling it. This API, whatever the APIs are present in the config service, the global config service will use it, but these are the APIs. So when you try to create an in-memory instance, right? So basically the global config service proxies that to the config service. So this is the API it uses, and the content remains very same. So here node selector also you can give node ID, node selector. So node selector and metadata are optional. So by default they are empty. So redis config defaults to an it's an empty keys. So we have again few more, like what are the error messages you will get, all those details are present here. How to delete the instance, how to create a config, sorry, how to set a config set operation for redis. So this is what the endpoint is. This is what the endpoint is. So we'll not be using it internally, just for a developer. So one who wants to develop systems, right? So they can use this system. So global config service, this we have seen for several APIs. So global FrameDB instances, this creates a in-memory instance in a multi-cluster. So you need to provide a cluster ID, FrameDB ID, and a node also. So this we have seen already. All 5 fields are required. Missing any returns 400, forwards to the target cluster config service, then stores the instance with cluster ID in the global registry. So delete operation, we have a get operation, get by cluster and a node. So those APIs we have already seen earlier. So it's a free form query, like Mongo kind of a query you can do, and get one particular instance. So that also we can do it here. And also you can do an set config. So it's the equivalent of config set. So that also we can do it. So and also for persistence, so you have same things. Uh, Create persistent instance. So you need to pass this JSON, and also you need to pass the storage type. So and also since you are calling a persistent instance, it creates the persistent instance. So same other APIs are also present similar to that. Like what you saw, only the instance was present. Here it will be persistent instance. So I'll not go in detail in explaining each of these APIs. So you have a so right now this is a service. So routing services. So base path is /FrameDB. So tracks where objects and streams live, but not the data itself. So whenever you do FrameDB objects, basically our library internally does this. Whenever you pass a key, so it register an object. So whenever you do a set object, this after dumping the data into the DB, the library calls this endpoint so that it dumps the metadata of it. So what is the object ID, and what is the FrameDB instance, what is the type, whether it is in memory or something, and this copies. By default, when you do a set object, right, so it will be by default it will be empty. Metadata also will be empty. Whenever you duplicate it, let's say you dump this key in one FrameDB and you want to make a duplicate of this, so you have made that duplicate, and then you need to update this copies. So for that updating also we have a APIs, so that this content will be updated with the duplicate content, like this is presented. Why we have to do the duplication? Let's say you have a cluster with two nodes, and you I just give an example. I am pushing one image from my I have one image, I want to push it so that the it can be processed in both of the nodes. So instead of keeping it in one node and pulling it, so what I do is, during the push itself, I'll push it to both the nodes, so that those images are locally available in those node, and that can be pulled by the algorithm running in that particular node. So it will be like a local access, so it again doesn't have to pull from somewhere else. So in such cases you have to make a copy of it. So to make a copy you can use the APIs. So right now this is not the content copying, it is the metadata information updation only. So it says that okay, it is available in this FrameDB ID, it also available in this particular frame ID. So when you do a get object, right, so let's say you are pushed to the both the nodes, and in the first node you are trying to do an get object. When get object sees it, it sees this is the FrameDB ID, and also it has a copies. So this is also another FrameDB ID. So it basically checks whether this is local to this node or not, whether this FrameDB ID is local to this node or not. So let's say this is one, it is running in node 1, it is running in node 2. If you are accessing in node 1, it sees this whether it is node 1 or not. So yes, it is node 1, so I'll pull it from this particular instance. So imagine it was in node 2, then it sees the copies. This is not node 1, so it's not node 2, so it is node 1, so I'll not take it. Let me see whether copies. So if it is node 1, oh sorry, it's node 2, so it will try to pull it from it. So basically data will be pulled from the local replica of the content. So and again we have a FrameDB objects, we have a post, so you can do update fields as well. Let's say you have size. Earlier you created a size, right, you want to update something or update the metadata or something like that, so you can do that update API. So you have update, and object ID also you need to pass here, and then delete also, deletion also you can do. So I was saying, right, so whenever you delete a FrameDB instance, its representation in routing services of not deleted, so it's your call whether to delete it or not. So it will stay it will be available there, so it's your responsibility to go ahead and check all the keys available in that DB and clean it. So you can use basically this API to delete the content. So the FrameDB objects, object ID get the metadata with one particular object ID. You can use a list query, so you can do what is an optional Mongo filter document, so you can pass a Mongo kind of a query as well for the list or a query. So it will get all the contents metadata, all the keys metadata from this particular instance. So you can do post also, register a replica, meaning you have a metadata, so you want to register a replica. So the content that I'm passing is this demo one other primitive instance, and it's an in-memory type. So this content will be dumped, like how you saw the copy, right? So somewhere you saw the copy. Yes, so this was the copyright. So basically this copies will be updated whenever you call the add copy function, sorry, the endpoint. So remove copy, copy exists. So these are certain APIs you have where you have to give a FrameDB ID whether it is present in this copy ID or not. So FrameDB streams, to register a stream queue, it was for a objects. So if you want to do something for a stream, you will use this. So this object is true for in-memory as well as a storage, whereas this is, since it is a stream, we have a separate endpoint for streams. So register a stream, stream is registered, streams queue name update, streams deletion, get one by stream name, so it is also possible. So next is a object API gRPCs. So we told that there is a service known as object service. So its APIs are also present. So it has only two RPCs, set object and get object. So I've explained already that it accepts protoc the set object request. Basically this is the parameter configurations, and it uses object, it has a string, like whatever you saw earlier, key, FrameDB, data, metadata type. So those things are also present here. So that's what we are returning whenever setting and giving the response, right? So whenever we are sending the response and setting the object, we use that object class, object message here. So so to do a set object, so you have to, I mean, you can directly use this FrameDB writer client. So this is the one second library that we have, where you create a stub operation. Like say you create a stub, you open a gRPC. That service is running in 3612. 3610 is for a global config, 61 for a routing service, 612 for a gRPC service, and you will create a channel and you will create a stub from that channel. Then you will be setting an object request. So you call the set object request and you will pass an object to it. So you'll pass an object and the object creation is here. So it is just the request and you call that request via stub dot set object. So when you call this set object request and you pass this request, it will dump the data and you will get a response. So this is how, if you want to do in a Pythonic way without the use of this particular the writer, the second SDK that we have. So so you can do a gRPC curl as well. I'll not go in detail. So whenever you do a get object, so stub dot get, so you need to say get object request and what is the key. So get object request accepts the key, so you have to pass the key, you will get the content. So this is for a for API reference. So let us see the object API. So using object API is the gRPC object service. So the object API is the gRPC object service exposed by object API. The port is this, and it is the canonical routing aware way to read and write objects bytes. It resolves the write FrameDB instance, performs the Redis TIDB IO, and registers the write with routing service as well. So same thing your FrameDB SDK was doing, right? It also does that, but uses a gRPC object service. So the service that we have hosted as one object API service, right? It uses that service to read and write the content from. So whereas our FrameDB SDK directly talks to the TIDBs and Redis, whereas here it talks to the gRPC object service, and within gRPC object service it will talk to the TIDBs and Redis. So you typically don't call gRPC directly from application code. Use the object API wrapper, which is there in the FrameDB writer client covered here. So the higher level FrameDB SDK, which talks to the Redis TIDB directly rather than through this gRPC service. So FrameDB SDK directly talks to the TIDB and Redis, whereas this writer client uh, uses the object service hosted and it talks to the via gRPC. So FrameDB instances must already exist from the FrameDB ID you write. Okay, so it's a prerequisite. I'll not explain again all this. So I have already given an example for it. So yeah, so now let's say in a previous example, we were doing stub and all those things from our side, right? So all these things we were only doing it, but to utilize the higher level API, so here we have a Python writer client, new object API client. So this is what you would be doing. So you will import this particular function, new object API client, and for this you will pass the gRPC 3612 port, which is a object API endpoint, and you will create a client and you will use a write to memory, write to persistent, and write to stream. So these three endpoints or these three functions are directly available, whereas in our FrameDB SDK you have to mention type equal to in memory or a storage or a stream for set object. If you want to do queues streams in the set object, you have to make type equal to streams, whereas here you have separate functions itself, the write to memory, write to persistent, and write to stream. So you don't have to mention type explicitly anywhere, separate function itself is present. So again, content I'll not explain. So write to memory, write to persistent, write to stream are thin convenience wrappers around set object and set type for you. So you don't have to call the set type. So key is omitted. If key is not available, it will create a UUID. So better you don't commit it because you will not get the keys again. So reading via object service, get object is defined in the proto but not currently wrapped. So yeah, so though this is available right now, we have not updated this library to do the reading operation. So you will not be able to use this library for a read purpose. So if you want to do a read purpose, then you have to do this particular proto things. So whatever we have seen in the previous example, right? So create a channel, create a stub, and then do a get object. So calling the gRPC services directly, any calling the gRPC services directly any language. So yeah, right now we just giving an example with the gRPC curl. So what happens server side? So again, I'll not go in detail, the same things will happen. So yeah, let us go to the writer SDK. So writer SDK, again, I have already did write to memory, write to persistent, write to stream. I have already spoken. And again, in the same library, in the same writer client library, two ways of access is possible. One is via object service and one is via FrameDB writer class. So this will directly talk to the RedSDB. It always uses the public IP. It will not check whether it's whether it's in the same cluster or not. It directly uses the public IP. Um, so here when you want to use it via this FrameDB writer, right? No FrameDB writer. So see here, this is the new object API client, whereas this is new FrameDB writer, and in that FrameDB writer you have a write operation. So write operation, you have to pass everything, whether updating is required to the routing service or not also is exposed here. So you need to do that. So both will be used only for writing, so not for reading. So which is the right one? Let's say choosing between the two paths, whether you want to use object API or a FrameDB writer, which one you want to use. So requires reachability for object API. Object API's gRPC port is already exposed via public, so it is directly accessible to the public. So but here Redis DIB exposes a public URL. So the public URL of those Redis and TIDBs are exposed, that will be utilized by this FrameDB writer. Whereas here uses the object API service that is running in 3612 port, 3612 port, it will be used. So next, local public URL aware. Yes, so server side cluster ID check. So in this gRPC will check whether it is in the same cluster or a different cluster. Whether it's if it is a local cluster, it uses the local IP. If it is a different cluster, it uses the public IP. So here that check will not happen. It will always use the public URL. So good for writers outside the cluster, centralizing write traffic. So if you are outside of the cluster, right, so you can use this. If you are not at all in the cluster, if you are in your local machine but you are trying to hit to the cluster, in such cases you can use this out of these two, and centralize write traffic because it goes via the object API service. So you are basically centralizing it. Whereas this is for whether it's the same cluster or not, it uses the public. So same cluster or a low latency writes script CLIs anywhere, you can use this. But as a preference, we will not prefer you for this. We'll ask you to use the our FrameDB SDK. So if you have FrameDB SDK and the FrameDB write client, so which one to prefer? So this is within the FrameDB writer client, which one to prefer? This is for these two, FrameDB SDK and FrameDB. If you only ever write, never read, and want smallest dependency surface, then use this. So your task is only writing, not reading, then use this. If you need to read objects back, store Python objects, cache results, backup data, consume streams, so in such cases you need to use this FrameDB SDK. Since it has so many things, we prefer you to use this particular SDK. So this is about the details about the FrameDB. So let us see something in action. Now let's see the examples of FrameDB. So let me go to the examples are provided in Infra Level Access folder inside the MemoryGrid. Just go inside that and the examples. So we have 4 examples kept here. So this is related to 2 related to FrameDB SDK and 2 related to writer client. In this FrameDB SDK, one example is for storage, write and read, whereas other is a in-memory write and read. These two are only write only, and one is for direct write and one is via gRPC. So first we'll go to the SDK storage write and read. So here we are reading the env file where it has all the IPs related to MemoryGrid global and MemoryGrid routing service URLs. So we'll read that, and we are creating a FrameDB client. We are providing those cluster URL and routing URL, and we are creating some random key here, and we are just dumping it with db.set object. So it takes a key, takes a FrameDB ID. This is a unique ID, and you have to provide what your data is and binary data, and type equal to storage. So this is must. A type needs to be provided, and any other metadata key value pair of a metadata. So this will dump the data into the storage. It is a storage type, and it is into this particular SQL 003 is the name of the FrameDB. And if you want to get the object, you just have to do get object the key. So you will get a found key in the response if it is set or if it is available, and then you can print all of the content. So this was the one example. So let me just show you the SDK write and read. So it is for a in memory. Earlier one was for a storage, and second one is for a in memory. So in memory, so type equal to in memory you need to set, and FrameDB ID you need to give, and also a binary data that you want to set the content. So again, same thing, you will do a set object and a get object. So get object, if you get a found, you need to check this found variable. If it is true, you can get other details like object. In that object you have data, FrameDB ID, type, and metadata. So this is using the FrameDB SDK. And with the writer client, so let me just go to the direct write. So again, you are reading all the load envs. You are taking the URLs, routing service URL and global config URL. So this new FrameDB writer is the FrameDB writer which is a direct one. So you need to import it. So you have to import it like this: FrameDB writer client, FrameDB underscore writer underscore client, import new FrameDB writer. So in that you can do write operation. You need to give a key. This is not a dictionary here. In our earlier example, we were sending a dictionary here. So we were sending a dictionary as a input, but here it is a key value pair set. So parameters you need to set: what is the FrameDB ID, what is the binary, and in memory, and also the metadata. So this is the direct client, so it will not go to the gRPC. So it uses the public URL of the FrameDB IDs. And this one is for gRPC service. So the object API, so you have to import uh, FrameDB writer client, new objects API client. If you, this is only for writing, not for reading. For reading, so I'm just using this FrameDB PB2 and FrameDB PB2 gRPC. So this is for a reading purpose, whereas writing only can done via this library itself. So new object API client, and this was a new FrameDB writer. So I'm just giving an example, though it is not a recommended way to use it. So you can use the FrameDB SDK itself. So you have to create a new objects API client. You have to give your object API service. So right now I don't require a service URL of a routing service or a global config. I require a MemoryGrid object API URL, so that I need to pass it, and then I need to do a client write to memory. So, and also I need to pass the content that I want to write. So here you don't have to pass the type because it is write to memory. And similarly, we have others as well, like write to storage, so write to stream. So those kind of APIs were there that you can utilize it. So this is the FrameDB instance, binary value, key, and the metadata. To get the object, so this is a gRPC stub.get object is what we are going to call. You have to create a channel, you have to create a stub. Using that stuff, you have to do get object, and what is the key you need to pass. So dot found you will get, and you can print it. So let me run this example. So the simple examples which you can use it, import it inside your agent code, and you need to import all the libraries that was mentioned. So agentic sorry, the FrameDB SDK and FrameDB writer client SDK uh, needs to be imported. So you need to dump this in your agent's code. uh, since we are asking you to prefer this particular SDK, you better copy this into your agent code along with all other agent libraries. So let us run one by one. So let me write first the FrameDB SDK storage write and read. So this is for writing into the storage. So as soon as we write is success, message is something object stored and routed successfully, and this is for a access reading. So found equal to true and the object key, and inside that all the content will be there, and also you have a message object served from the cache. So because I have used the same library in the same code it is running, right? So it has used it from the scratch cache. So if it is not available, it will pull it from the DB. So this is the content, and this way you can, this is the content of each the content of the object. So this is a storage. So let me run the write SDK. So read and write for a in memory. So same thing, you will get objects stored and routed successfully, and objects are from the cache, the same content. And let me just run it for direct write. So root failed for key, sample key. Well, that's fine. You can ignore that, but it is a success, write successful. And this is the sample key. This is for a direct write. So only you can do right there. So let me just run gRPC. Yes, so success is true, object stored and routed successfully. This is the key, and this is the reading via stub. Hello FrameDB. This is the content that we have dumped from here, and demo instance to memory. That's what I'm printing it. So object data, FrameDB ID, object type. So that's what it is printing here. So these are the three, four examples that I want to show. So okay, so that's it, I guess, in the FrameDB memory. So context memory also we have shown, and also FrameDB memory examples and usage also shown. So thanks for watching, and don't forget to subscribe our channel. Thank you.